Hello students. Now we are going to see, we have reached at the third part of the projectile motion where we are going to discuss some special characteristics in the trajectory of the projectile or in the motion of the projectile. Okay. So to recall first the previous formula which we have derived in the first class, we have to draw the initial velocity, the velocity with which the projectile is thrown, with the angle of inclination theta. We have taken the component of u along x-axis in horizontal direction, that is ux, and the component of u along y-axis, that is uy. We have found the range of the projectile was ux into t. T is the time of flight. T itself is 2 ui by g, and the h equal to ui square by 2g. There are some hidden assumptions which are actually discussed in the first class and whose link will be given with this video when it will be uploaded in YouTube. Okay, so these are discussed in very detail, and h is the maximum height. I think everybody can remember that. T is the time of flight, and R is the range, horizontal range. But we actually didn't stop there. We moved to calculate or to see the trajectory, how the trajectory of the projectile motion is, and we have found a trajectory. This is the trajectory actually, and we have found the equation of the trajectory. The equation of the trajectory is given by y equal to ax minus bx square, which is the equation of parabola. And from the former analysis, we have found that a by b equal to r. R is the range of the projectile. Okay. Today we are going to see the two important facts, and that will be very helping. That will be helping us in JEE and NEET to solve some problems. These characteristics are very essential. That's why I have kept them separated from the other lectures. So now we are going to uh, draw the picture again to show you what are the characteristics we are going to talk about. So it is easily visible from the equation of trajectory, that is y equal to ax minus bx square, that it is a quadratic equation of x. This quadratic equation implies that if I solve this equation, that is the equation is bx square minus x plus y equal to 0, then we will have two roots, x1 and x2. And for the both these two roots, we will have the same y. Right? This equation is telling that. This implies that when a projectile is thrown, it is actually it is visible from this picture that the projectile will reach at the same height at two horizontal positions, and that these horizontal positions are given by the x1 and x2. And that is a significance, a physical significance of this equation. It is telling that the projectile will reach the height at twice. So here, that is y, and here, this is y. So when it is ascending, it will reach at y, and when it is descending, again, it will reach the height y. And the first one is reached at x1, and the second one is reached at x2 from the origin. So, so that is so this is the physical significance of those roots of this quadratic equation. Okay. Now I am going to rearrange them. What I'm going to find the sum of these x1 and x2. So our aim is to find our aim is to find the sum of the horizontal displacement, that is x1 plus x2. Okay, so let us do this. So if I rearrange the terms like this way, so if I divide the whole equation by b, so it becomes x square by a by b, x plus y by b equal to 0. We know that if any quadratic equation can be written as x alpha x plus beta equal to 0, the alpha is actually the sum of the roots and beta is the product of the corresponding roots. Okay, we can, if I compare these two equations, we can easily see that in the place of alpha, a by b is there, and in the place of beta, y by b is there. Right? We can easily see after comparing these two equations that in the place of alpha a by b and in the place of beta it was y by b. That means the sum of the horizontal distance we have found, which are the roots of the quadratic equation, that is a by b. And the product of the roots is giving me the y by b. So what we have achieved that x1 plus x2 we have found a by b, but since uh, we have already known that a by b is the range, that means that x1 plus x2, the sum of the horizontal distances at which the projectile can reach the same height, is the range of the projectile itself. So this is very important data. So if somehow I know the value of the x1, okay, if the x1 will be given for a projectile motion that a particular height is achieved at x1, then I can easily find the x2 when the projectile again is found at the same height. Okay. So, so that is used so that x2 is r minus x1, and it can help to solve various important problems. This can be taken as a trick to solve various problems. Okay, so this is a very important thing. So next thing is again we are going to discuss that when a particle when the projectile can reach at the same height twice at two moments. Now we are considering the two moments where it can reach at the same height. So suppose the projectile is thrown with a initial velocity u and with a theta, and it can reach at this point p, say at a height y, and at q at the same height y in two moments. So the time it takes q1 to reach at p is taken, and the time to reach q from the initial position is taken to be t2. So like the previous case where we have found the horizontal distances, corresponding horizontal distances, the sum of the horizontal distances is the range of the particles. So we are going to now see that what is the sum of the moments or the sum of the timings. So we are going to see that T1 plus T2. Okay. Got it. So let us first see that how can I find that. So I have taken any one of them, any one of the point P or Q, and decided to write the time as t as a variable. So if I write, so the u has an initial velocity along y direction is uy, and which will participate to find the y. So y is equal to simple u by t minus half t square. Again, if I rearrange the equations, it becomes half t square minus u by t plus y equal to 0. So it is a quadratic equation of t itself right now. So again, I am going to rearrange them. So that is 2 ui by g plus 2 y by g equal to 0. Right. So like the previous case, we have discussed for the quadratic equation of x. So it is a quadratic equation of t. It has two roots, t1 and t2. And for t1 and t2, the same y can be found. And that is happening actually in the path of the projectile, right? So that is t1 and t2. So sum of the t1 and t2 is simple 2 ui by g. But from our first lecture, from our the first class, we know that the 2 ui by g is actually the maximum height. Sorry. This is the time of flight, and we have already discussed in the beginning of this class that it is a time of flight here, right? It is the time of flight of the projectile motion. So that is t. So so we have found that when a projectile is thrown, when it can reach the same height twice at two moments, at two time, that is t1 and t2, then the sum of those time is the time of flight. Very, very important characteristic of the projectile motion. Because if the T1 is known, then I can find the T2 easily. And that can be helped us to solve various MCQs. Okay. Okay. So this is the very important thing. Next characteristics again, very important thing. Next characteristic. So that is called radius of curvature at any point. At a point P in the trajectory of the projectile. That we are going to find this. Okay. So let us find that first. So what is to know about the radius of curvature? We have to first define what is the radius of curvature. So what is that is suppose this is the projectile motion, and it is along y-axis, it is x-axis, same. And in the trajectory in this motion, we have to find the radius of curvature at the point P. So initially, this is along u. This is u initial velocity. This is we have taken the angle of inclination is theta, but now we are going to find a particular the radius of curvature at the point P. To get that, first we have to draw the tangential velocity at this point here, which is say v, because due to having the gravitational acceleration, the velocity will change, right? Its direction and magnitude will change, and that is why at the point P, v is totally different from u. Yeah. Now we are going to define the first radius curvature. We have to know what is the radius of curvature. The radius of curvature is telling me that take the v, this v, at any instant of time, take the v as a tangent of a circle. So you have to draw a circle here, and whose tangent is actually giving the direction of the V. Then if I join the point P or P and the center of the circle, okay, then the radius of the circle, this R, is called the radius of curvature. Simple. So the step number one, step. So let me give the steps. Step is to find the circle whose tangent is the V. Then the radius of the circle is the radius of curvature. Okay. Now what we are going to do is I'm going to draw a horizontal line here. So this angle, the angle the velocity makes with the horizontal line is said to be alpha. Say, okay. And the G is acting downward here. So if this is alpha, then this angle must be alpha. You can check from the geometry. So this is G, and his components, the angular acceleration, the component of the G along the radius, that is the radial acceleration, is given by G cos alpha. This is easy to see from the picture. Okay. So you can actually imagine if you have any problem to understand why is it so alpha. So you can understand that from the inclination plane problem. Okay. So if this angle is alpha, say, then this the G, the component of the G perpendicular to the plane is G cos alpha. The same thing is happening here. Okay. So G cos alpha is the radial acceleration in the sense that it is directed along the radius of the circle. So we know that when a particle is moving in a circular motion, the acceleration towards is pointed towards the circle, which is called as centripetal acceleration. So G cos alpha is the centripetal acceleration, and the formula of the centripetal acceleration is that is v square by r. And from this formula, we have found the radius of curvature, that is v square by G cos alpha. So that is the radius of curvature. So let me give you some example so that we can find how to calculate the radius of curvature of a projectile motion. So we have taken, so what will be given in the examination? So u, the initial velocity will be given, the angle of projection is given theta, and the height y can be given to find the radius of curvature. Uh, Height means the height of the point P from the ground. So again, I'm going to draw this to make you understand better. So suppose this is the point P and this is the height y. So the u is given. So now I'm going to take a data. So u is 10 meter per second, sir. Okay. Y is given, say, 2 meter. Okay. And the angle of theta is given, say, 60 degree. I'm taking. Hmm. And we have to find the radius of curvature at the point P. See here, I have to draw the first V. So this is in this direction, that is Vx, and that is Vy. This is say alpha. We have to first. So our target is to find V square. In the formula, the V square is present. and the alpha is present, right? We have to, and G is taken to be say 10 meter per second square for our simple calculation. So we have to find this. So R, the formula is containing V squared by G cos alpha, and V squared is Vx square plus Vy square, right? By G cos alpha. So we have to get this Vx and Vy, and from there we will get the V square and cos alpha we have to find. That's all. From the first class, we know that very important characteristic in a projectile motion is that at every point, the horizontal velocity, since there is no force along the horizontal direction, the horizontal velocity remains same. So at every position here, the horizontal velocity remains same. So initial horizontal velocity was u cos theta, which is ux. This must be equal to vx. So vx is already found. The first job is over. So that is u cos theta. U is given 10 cos 60 degree. That means it is 5 meter per second. So that is done. Next thing, we have to find a Vy. Vy, how can I find it? So now we are considering the vertically upward motion, which is being retarded by the gravitational acceleration. Okay. And for that case, we can write the V square, Vy square equal to Uy square minus 2Gy. Okay. And Uy, what is Uy? Uy is U sine 60 degree. And that is Uy. What is Uy? I'm going to put that. So U is 10, sine 60 is root 3 by 2. So that is 5 root 3. So that is 5 root 3 whole square minus 2Gy. 2, 10, and 2. Because Y is taken 2 meter. It is 25 into 3. And that is also the right. So that is 40. So so this is 75 minus 40. So it is 35. So Vy square we have found 35. Okay. So V square we have found Vx square plus Vy square, and that is we have found it. So that is a very easy way to get that. So here uh, 5 square plus 35, that is 25 plus 35, that is 60. Okay. But so this can also be found. This velocity, the v square can be directly found if the mass of the particle also given. Okay. But I have not talked about the mass here. So without the mass can be, so this can be found in different ways. So I am going to show you a second method. It is much more easier if you use the energy conservation principle, because the particle is moving under gravity and gravitational force is conservative force, that you can use in uh, energy conservation principle here, that my total energy at the initial position O is the total energy at the position P. So total energy at the position O is simply the kinetic energy half mu square, and total energy at the point P where it actually can reach a height y. So here the potential energy is mgy, right? So I'm going to write that. So that is half m v square plus mgy. So it becomes then u square equal to v square plus 2gy. So is v square is equal to u square minus 2gy. It is much more shorter case. So u is given 10, 10 square, 2 into 10 into 2, that is 60. So it is much more easier to get this. It is much more shorter way to a shortcut way to get the v square. So we have found the v square. So our last task is to find the alpha. So alpha can be found at tan alpha. So the velocity in this direction I'm going to draw that. So this is v. So here is vx and this is vy and this is alpha. So tan alpha is simple vx by vy. Sorry, vy by vx. Which is right. But what is Vy? So we have found already Vy. Vy itself, what is Vy? Vy is Vy square is 35, right? So we have to write that. So Vy is 35, root 35, and Vx is itself the horizontal component of the projectile, which is same, so that is 5. Yeah. Okay, so this is tan alpha. We have found the tan alpha. So from the tan alpha, we can find the cos alpha. Okay, how can I find the cos alpha? It is also a shortcut to get this. So I will assume this is perpendicular and this is base. So that is root 35 and this is base. So the hypotenuse is the sum of that, that is root 60. Okay, that we have already found for the velocity, right? So that is so cos alpha. What is cos alpha? Cos alpha, so this is alpha. Cos alpha is simple 5 by root 60. Okay, so our job is over. So R becomes v square by r cos alpha. So can you see that? Yes. So let us okay. Let us do this first. So I have done a mistake, a small mistake, a typo. That is G should be here. So I'm going to put it up. So V squared is simple. So V squared is 60. G is 10, and cos alpha is 5 by root 60. So it becomes simple 6 into root 60 by 5. It can be simplified more. So that is 6 into root 60. Root 60 is 2 root 15 by 5. That is 12 root 15 by 5. Okay, that can be calculated by the calculator, but it was my intention to show how to calculate the radius of curvature, and that is the final. So that should be in meter. So that is the way to find the radius of curvature at any point of the projectile motion. Okay. So that is I have also shown a shortcut to get the velocity at any position without getting the angle well, without knowing the notion of the mass of the particle. So this is a very easiest way to get the v square. Okay, so that is a shortcut we can say, and we have solved the problem to find the radius of curvature. Okay. So at any point, so at the point P, the radius of curvature at the point P is given by this. So after that, you will calculate or the value of this from the scientific calculator. You can get the value, or there are various other ways to get the value using the binomial expansion of the root 15. Okay, so you will get the value all by hand. So I'm leaving the class here, and that is when. And in the next class, we will again find other important problems regarding the projectile motion. Thank you.